Let's look at some addition and subtraction formulas or identities for sine and cosine. First, I want to note a characteristic of these functions. The sine function is what we call an odd function. The sine of negative x is the negative of sine of x for all values of x. Cosine is what we call an even function, and that means that cosine of negative x equals cosine of x for all values of x. It really doesn't matter whether the input is positive or negative, we will get the same output value for cosine regardless. I want to use that property to derive one of our subtraction identities in this video. I'm just going to give you the first addition formula. We say that cosine of a plus b equals cosine a cos b minus sine a sine b. I'm not going to prove that in this video. Hopefully you will see a proof in class or find a useful one online. But given this formula, I want to imagine what happens if we replace b with negative b, i.e. if we are trying to derive a formula for cosine of a minus b. Well, I would have cosine of a cosine of negative b minus sine of a sine of negative b. Now cosine of negative b is the same as cosine of b because cosine is an even function. So I could write this simply as cosine a cosine b, and sine of negative b is the negative of sine of b. So if I take the negative of a negative value, I'm going to get an addition sign here, and I can say plus sine of a sine of b. This is the simplest identity we have for cosine of a minus b, derived from the addition formula. In a similar way, we have identities for sine of a plus b and sine of a minus b. Now, I will admit that this is a lot to remember. However, there are some common patterns among these four identities. Some memory aids that we may be able to use. Notice that the sine formulas have the same sign, positive or negative sign, as we see in the angle addition or subtraction. If we are finding the sine of a plus b, we will be adding together some terms. If we are finding the sine of a minus b, we will be subtracting some terms. Cosine formulas have the opposite sign. If we're finding cosine of a plus b, we will use subtraction. If we are finding cosine of a minus b, we will use addition. Sine formulas begin with sine of a. Cosine formulas begin with cosine of a. There are some other common patterns that hopefully you can pick up on to help familiarize yourself with these formulas. Let's look at two examples using an addition or subtraction formula. These formulas now allow us to evaluate angle measures beyond multiples of 45, 30, or 60 degrees. For example, I can evaluate sine of 75 degrees using angle addition by writing 75 degrees in this way. I could say sine of 75 degrees is the same as sine of 45 degrees plus 30 degrees. And I can apply my angle addition formula. This is equal to sine of 45 cosine of 30 plus cosine of 45 sine of 30. Over here on the left, I have our special right triangles for reference, and we can see that sine of 45 is sometimes called 1 over root 2. I'm going to rationalize it and call it root 2 over 2. Cosine of 30 degrees is root 3 over 2. Cosine of 45 is also root 2 over 2. And sine of 30 degrees is 1/2. If I combine this, we end up with square root of 6 over 4 plus square root of 2 over 4, or you could say root 6 plus root 2 over 4. This is an exact value for the sine of 75 degrees. In our second example, I would like to find the cosine of pi over 12 using angle addition or subtraction. It may help first to remember that pi over 12 is the same as 15 degrees. Sometimes it's easier to determine how to do this addition or subtraction if I convert to degree measure. So I want to find cosine of 15 degrees. And I could say here, this is cosine of 45 degrees minus 30 degrees. That's one way, not the only way, but one way to get the difference of 15 degrees. Well, using our cosine subtraction formula, this is cosine of 45, cosine of 30, plus sine of 45, sine of 30. And once again, from my special right triangles, I can find all of these values. Cosine of 45 is root 2 over 2. Cosine of 30 is one that we saw in the last calculation, root 3 over 2. Then I have root 2 over 2 and 1/2. We will see a lot of the same values being repeated throughout these measurements. They all come back to angle measures of 30 degrees, 45 degrees, maybe 60 degrees. So we see here that the cosine of pi over 12, or 15 degrees, is actually the same value we reached in the last example. It's the same as the sine of 75 degrees. That should not surprise us because those two angles are complementary. They add up to 90 degrees.